Okay, let's move on to inverse function. So now when it comes to inverse function, okay, the first thing you know is the idea of what type of function, what type of relation has an inverse, which types do not have inverse. Okay, so now I hope you still remember, if you have one-to-one, if I go from left to right, one-to-one relation. So let's say this fx, fx is 1-to-1. So when you go the opposite direction, we call it f inverse. This is also let's say 1-to-1. So 1-to-1 is a function. So in this case, if your original function is 1-to-1, then it has an inverse. Okay, I'll give you another example. We know earlier that if the function is many to one, sorry, I need to write this as many to one. Wait, let me change it. Many to one is also a function. Many to one. Let's say this is a many to one function. So if I go from left to right, yes, this is many to one. But if I go from right to left, this my f inverse is a one to many, and one to many is not a function. So that's why we say many to one relation has no inverse. Only one to one has inverse, right? Okay, maybe I give you a simple example. Okay, let's say this is the graph of fx equals to x cubed plus 1. Okay, explain. Do you have an inverse? Okay, very simple. We draw a line, vertical line. Okay, sorry, I think I need to use this vertical line. This is your x value. There's a corresponding y value. So this is a 1-to-1 relation. So does it have an inverse? So fx has an inverse. If I give you another example, say a quadratic, let's say fx equals to x minus 1 squared plus 2. Okay, does this function has an inverse? Answer is no. Why not? We draw a line horizontally. You can see this x value and this x value, let's say they share the same y value. So this is a many to one relation, and many to one relation has no inverse. Okay, simple, right? All right. So moving on. So you know this the type of relation that has an inverse, but we're going to talk about how to find inverse function. Now for simple function, right, I think you can just do it mentally. In exam is only 1 mark. For example, if I have fx equals to x plus 3, a classic example, plus 3, if I go from left to right, it's just plus 3, like 1 plus 3 is 4, 2 plus 3 is 5. So your f inverse is just opposite. So it's, okay, I wrote wrongly here. So it's just x minus 3. So if I say gx equals to 2x, so what do? The g inverse opposite operation is x over 2. If I say hx equals to square root x, your h inverse x, the opposite operation is just square. Now, however, there are two functions is a bit unique. Okay, the reciprocal and the 1 minus k minus x. Okay, this is very unique function. Let's say the first one is, let's say k over x. Okay, because when you inverse it, the function is the same as the inverse. Okay, maybe I just give you a simple example. So let's say this is 6. If I put 1 inside, I get 6, right? If I put 2 inside, I get 3. If I put 3 inside, I'll get 2. So, but if I go the opposite direction, imagine this, I put 6 inside, 6 over 6, I still get 1. I put 3 inside here, 6 divided 3, I still get 2. 6 divided 2, I still get 3. So this is a function. The inverse is the same as the function itself. Later I'll show you the calculation method. And another type is this. Let's say I'll just take 2 minus x. Okay, same thing. When you put, let's say I put 3 I put 1 inside. 3 minus 1, I get 2. 2 minus 3 minus 2, I get 1. 3 minus 3, I get 0. But when you go opposite direction, you're getting the same thing. Your f inverse is also 3 minus x. Now, generally, for fx equals to k over x, or fx equals to k minus x, your function is the same as the inverse. The function is the same as the inverse. Okay, but this is the first part. I just want to explain the more complicated one. Not to say very complicated. Let's say you're 2x minus 5. Okay, so how do you inverse it? Okay, number one, when you to inverse mentally, remember, Number one, the operation must be opposite. Number two, the sequence also must be opposite. Now here, when you minus 5, you minus 5 plus you first times 2, then you minus 5. So the opposite operation will be first you plus 5, then you divide by 2. Yeah, the sequence also will be opposite. You minus 5. The opposite of minus 5 is plus 5, but you plus 5 first, then only you divide by 2. Second example. Okay, let's say this will be let's say I put a square root with the square root x plus 4. So what do I do first? Number one, opposite of square root is square. Number two, plus opposite of plus is minus. Okay, the third one is a little bit tricky. All right, let me give you 2 over x minus 1. Okay, so here's the thing. When you inverse, what I do first? First you plus 1, then you do 1 over. In fact, this is 2 over. Remember I say for this type of function, the function and inverse must be the same. So 2 over x, so just invert it, you get this. Yeah, another one, maybe I put kx. If you think this is a bit confusing, so I'll just show you another example. So let's say I use 3, like 3 over x minus 4. So my k inverse will be first you invert it, then opposite of minus 4 is a plus 1. But if you think this is a bit complicated, don't bother, we use the standard method. Okay, what is the standard method? The standard method, let's say I give you a classic example, 3x plus 4. So how do you inverse it? We let this becomes y. By the way, I need to say this because some of you, if you're using the textbook use fx equals y. Okay, I don't like this because I feel it's a lot slower, especially when we want to find the number. For example, I show you an example here. So let's say I want to find a numerical value here. I want to find f inverse, let's say 5. Okay, so if I let f inverse 5 becomes y, I can write fy equals to okay, 5 will be a ugly number, so let's say how about negative 5? Negative 5 will be better. Fy is now negative 5. So 3y plus 4 is now negative 5. 3y is negative 9. Y is now negative 3. So my f inverse negative 5 is just negative 3. Right? Now notice I don't have to inverse the function. But if you're using this method, I know you guys will be like, okay, 3x plus 4 equals to y. 3x equals to y minus 4. X equals to y minus 4 over 3. Okay, make f inverse x I'm finding f inverse x x minus 4 over 3. Then you put inside. In my opinion, it's just way slower because you have to inverse the function before you can sub inside. Right? The first method you don't have to, or you can do it directly. Right? And by the way, if you just want to find f inverse x equals to y, if you want to find in terms of x, remember we can switch this. Yeah. Let me explain the switching. Let's say we start with x. When you inverse, you're going in the opposite direction. Let's say you end up at y. So, but if I start from y, I'll move from here, fy, my result will be x. So y is your object, x is your image. So then we just substitute 3y plus 4 equals to x, make y as a subject, x minus 4 over 3. Therefore, your f inverse x is x minus 4 over 3. Yeah, simple, right? Okay, now going back to the mental calculation. Now, I mentioned just now some questions are quite simple. You can actually inverse it mentally, but some you can't. Yeah, not to say you can't at all, but it's way harder to do it. Example, let's say fx equals to 2x minus 3x plus 4, something like this. Now, it's a bit difficult to do mentally because you got double x. So to do it the standard way, we let this becomes y. Fy is now x. 2y minus 3y plus 4 equals to x. So you want to solve for y. So 2y minus 3 is xy plus 4x. We can bring over, this is 2y minus xy equals to 4x plus 3, right? So make y as a subject. So 2 minus x, 4x plus 3. Y is 4x plus 3 over 2 minus x. And your y is your f inverse x. And this is 4x plus 3, 2 minus x. Okay? Now, but I do have a shortcut though. But this shortcut, you may say is a bit illegal in exam. Is ax plus b, cx plus d. This is actually using the idea of inverse matrix. Some of you have done this. Now, in matrices, when we inverse it, right, what you do is you switch the determinant, right? We switch the position of A and D. So I put D here, I put A here. We put a negative in front of B and C, right? Remember to keep your X. Then this will be a positive A, because you just A is positive, let's say. Now, look at this function here. So we try to do it one shot. My A is 2, my D is 4, so I switch 4 here. I put 2 here. I put a negative in front of B. So this is if you put a negative in front, it becomes a positive 3. And C is negative, a positive 1, so it's now negative X. Keep the X here, put the plus sign here. Now I want you to compare this one and this one. Are they the same? They're the same, right? Just so fast and furious. But of course, you got to remember, let's switch the position, put the negative in front. But in the exam for SPM, then I would use this method to double check my answer. This is still a standard way of doing it. If you don't want to lose marks in the exam, please use the standard way here. Okay, so I guess that's most of it, right? Okay, but a couple of things about inverse, a couple of relation about inverse, that is, let's say you're given f inverse x. Do you know what's the answer? The answer is just x. So now, what is the meaning of this? Let's say we start from x, you do f inverse first. Say the result is y, right? So then you're going to go forward, because you already done this, right? Your f inverse x is already y, and starting from y, I move forward, I end up getting back to x. So this is a true formula for all values of x. So for example, I may give you g inverse of 5. Answer is just 5. Now, on the other hand, what happens if I give you f inverse fx? Well, it's the same thing. You still get x. Why? This time I start with x. I move forward, I get y. Let's say I move forward here. This one I get y. And starting from y, I go backwards, f inverse y. Where will I end up? I will end up getting x. Yeah, so this is still x if you want to write like this. Yeah, so example, what is f inverse f? Let's say x plus 3 equals to 7. Answer? Just cancel them. X plus 3 is 7. X is just 4. Okay, so this part, no problem. Okay, some other things. Okay, sometimes you may have to use comparison, like I give you fx equals to x minus a over 4, and my f inverse equals to, let's say, bx plus 5. Okay, how do you find the values of a and b? Very simple. We take the first function, inverse it, and compare with the second one, or you take the second one, inverse, and compare with the first one. So let's say I take the first one. I let f inverse x becomes y. So fy is now x. Y minus a over 4 is now x. Y is now 4x plus a. This is your f inverse, 4x plus a. And this is also your f inverse, bx plus 5. So by comparison, b is just 4, a is just 5. Very straightforward, right? Yeah. Sometimes they may put unknown inside, and you're supposed to find the value of unknown. Okay. A couple of other things will be like they combine composite function with inverse function. Let's say I have fx equals to, let's do something more difficult. The rest are too easy. Okay. So let's say 3 over x minus 2. And okay, I don't want to use 3. Maybe I use 6, because 6 usually you get a nice answer. So I'll just take 6. Okay. And then your gx equals to 4x plus 5. Okay, so let's say I want to find gf inverse 1. How about this? Gf inverse 1. Now this one looks difficult. I don't know. Not difficult actually. So how do you find gf inverse 1? So again, I don't want to find the inverse function of f. I let f inverse, okay, f inverse 1 becomes y. So fy becomes 1. So 6 over y minus 2 is now 1. 6 over y is now 3. Y is now 2. Yeah. Now notice, I didn't inverse the function for fx, I just straight away solve for y, and y is my f inverse 1, right? So my f inverse 1 is now 2, so this is now g2, put the 2 inside. This is very straightforward, answer is 13. But what if I want to find, let's say, g inverse fx? Okay, now this time, you need to inverse the function. We know fx is now what? What's fx? My fx is now 4x plus 5. Okay, but I still have to find the inverse function. But since this function is quite easy, so we can inverse mentally, right? G inverse x is what? Can do it mentally? X minus 5 over 4, right? Yeah, first you minus 5, then you divide by 4. Wait, I think I made a mistake. I put the wrong value here. So this one, sorry, your fx is now 6 over x minus 2. Looks complicated a little bit. So I'm going to put 6 over x minus 2, then minus 5 divided by 4. This will be 6 over x minus 7. When you divide by 4, it's the same as times 1 over 4. Well, answer is not pretty, but it's okay. 7 over 4. Yeah. If you want, you can combine it as a single fraction. If you don't, it's still okay. Now, just so you know, some people may say, oh, can I do it this way? I times top and bottom by x. So I get 6 minus 7x over 4x. Is it the same thing? Yes, they're actually the same. Okay, so I wonder what else I haven't covered. I think most of it. Yeah, it's done. So please try the rest of the question. You can do the rest of the question. If you have any problem, let me know. Yeah, I will just explain. Okay.